Well, good morning. This is 9:39. I waited 9 minutes to see if anyone was going to show up. They haven't. I had thought about maybe waiting till 10 and just doing 10 till 10:45. That's when class would have met. But then I saw an email that the dean has called a meeting at 10, so I better get started now because I'm going to have to stop at 10. But so right now nobody's here, but we're going to continue from where we left off last time. So here we go, if it'll ever do. Okay, we're on Chapter 4, Trigonometry, 4.3 Right Triangle Trig, top of page 285. Okay, in the last example, if you remember that, let me go back one. No, it wasn't. It was the last example, but it was on the slide set. Okay, sorry, and they're not showing here. But in example 9 that we did in class, we used the fact that theta equal 30 is an acute angle, satisfies the equation sine 30 is equal to 1/2. Suppose, however, it says by now you're able to recognize that theta equal 30 degrees is the acute angle that satisfies the sine theta equal 1/2. We did that in the last problem. Suppose, however, that you are given the equation sine theta is equal to 0.6, and you are asked to find the acute angle theta. Okay? Well, you know that sine 30 is 1/2, and sine 45 is 1 over root 2, or root 2 over 2, which is 0.707. So you can guess that the theta is somewhere in between 30 and 45 degrees. Now, we will come up with a better way to do this and say, well, it's between 30 and 45, but we aren't quite there yet, but we will get there. Okay? Now, that was the last slide in the slide set. There is one more example, and that's example 10. So let me go on and do example 10. Again, this is solving a right triangle. So let me see if the pen will activate. Here we go. Find the length C of a skateboard ramp shown in the figure. Find the horizontal length A of the ramp. Okay? Here is the ramp. That length right there is A, the horizontal length. We know that they give us that this is 4 feet tall at the end. Okay? And they give us that the angle here, this is C, that's the length of the ramp, that's what we're looking for. They tell us this is a perpendicular line that's shown in the graph by that little square there. And they tell us that this is 18.4 degrees. Okay? Now, what we see from the figure, we're asked to find C and then to find A. What we see in the figure, we know this angle here, 18.4 degrees. We see that this is the right angle. That C must be the hypotenuse, so this is the opposite side. Well, what trig relationship links an angle, its opposite side, and the hypotenuse? Well, of course, that's sine. The sine of angle theta is equal to the opposite side over the hypotenuse, some old hint. Okay? So what we have here is that the sine of 18.4 degrees is equal to 4 divided by H. I'm sorry, C. Since we're using the figure, we'll call that C. Okay? 4 was the opposite side, C is the hypotenuse. Well, we want to find C, so multiply both sides by C. You don't find C when it's in a denominator. You get it into a numerator by multiplying by C. And then divide by sine of 18.4 degrees. All right. Well, the sine of 18.4 degrees goes out here. That leaves you only C. So C is equal to 4 divided by the sine of 18.4 degrees. Now, how do you do that? Be sure you're in degree mode. And then enter on your calculator just like you see it, 4 divided by sine, opens a parentheses, 18.4, close parentheses, equal. And according to the text, that's going to be something about 12.7 feet. Approximately 12.7 feet. Now, frankly, I don't see how they get that many significant digits. Well, yeah, the 18.4 has 3 significant digits. They didn't say the 4 was 4.00. If this was a physics class, you would require that, but it's not. So you can do this. Now, the next question is, and so this is approximately 12.7 feet. Okay? That's what C is. Now they ask for A. Well, there's a couple ways you can get there. One way is, you know the hypotenuse and one side, you can use Pythagorean theorem. Here's the only reason I have a little bit of problem with doing that. This is an approximate answer. We rounded here. So therefore, whatever round-off error we have in it is going to carry through and enter A. I think a little more precisely would use our trig function. What trig function relates this angle, 18.4, to the opposite side and the adjacent side? Well, that would be the tangent function. So tangent of 18.4 degrees is equal to 4 over A. Multiply both sides by A, and then divide both sides by tangent of 18.4 degrees. Okay, and just because I'm running out of room, I'll go write that again. So the tangents 18.4 go out, and A is equal to 4 divided by the tangent of 18.4 degrees. Again, be sure you're in degree mode, in case your calculator automatically goes back to a radian. Most of them don't, but in case it did. And then A is equal to 4 divided by tangent, that opens a parenthesis for you, 18.4, close parentheses, hit equal, and you should get an answer approximately 12.0 feet. Okay, now that's what the book got. I don't have my calculator in here with me, and I was hoping someone would be here to do the calculations. Okay, now does that make sense? Well, yeah, that looks pretty reasonable. You know, C's the hypotenuse. It has to be longer than either of the sides. Certainly it's longer than 4 feet, but it's even longer than 12 feet. Okay, now I would use the Pythagorean theorem just to check and see if your answer makes sense. Okay, now I'm going to, goodness gracious, how to do this. All right, I'm going to jump out of this for a minute. Okay, remember 12, 4, and 12.7. Okay, so I'm going to discard that for just a moment and go to my calculator. I can't do this because this calculator, I don't think, let's see, no, I was thinking there was a way to expand this. I didn't bring my phone in here with me either, so I can't do a trig function on there, so sorry about that. So let's go back to this again. All right, so already lost. There is a checkpoint at the end of that example 10. Please do the checkpoints. Okay, if you were here, we would do vocabulary. Okay, I guess we'll just do it real quickly. Match each of the trigonometric function with its right triangle definition. Well, sine is certainly the opposite over hypotenuse. That would be Roman numeral 5. Cosine is adjacent over hypotenuse. That would be Roman numeral 4. Tangent is opposite over adjacent, Roman numeral 6. Cosecant is the reciprocal of sine, so that would be hypotenuse over opposite, and that would be Roman numeral 2. Secant is reciprocal of cosine, that would be hypotenuse over adjacent, that would be Roman numeral 1, and cotangent is the reciprocal of tangent, so that would be adjacent over opposite, and that would be Roman numeral 2. Number 2, relative to the acute angle theta, the three sides of a right triangle are the, and it doesn't matter what order you do, the opposite side, the adjacent side, and the hypotenuse. Could have said the adjacent side, the opposite side, and the hypotenuse. Cofunctions of complementary angles are equal. That's the blank that goes, the word that goes in there. And then number 4, an angle that measures from the horizontal upward to an object is called the angle of elevation, whereas an angle that measures from the horizontal downward to an object is the angle of depression. All right, then 4.3, homework exercises. Do either 5 or 7 or both, either 9 or 11 or both. Any of the odds 13 through 19, any of the odds 21 through 29, any of the odds 31 through 39, any of the odds 41 through 45, any of the odds 47 through 55, any of the odds 57 through 61. Trying to remember where we picked up. I think it's probably in the next. Finding the side lengths of a triangle. Either 63 or 65 or both. No, I think I assigned those two. And I think I assigned all these, in fact. Any of the odds 67 through 77. But now you have another example or two to base those last problems on. Now the exploration, you can always do those if you choose. There are 3 true-false questions. Be sure to, I think those answers are in the back. If they are, at least the odds, make sure you understand why it's true or false. Okay, if you don't, bring it to class and ask, or see me in office hours. And then the think about it are exactly that. Think about those and see what they're addressing there. All right, I don't have much more time, so I was wanting to start on 4.4. Wrong thing. Intro. Yeah, that's what I want. Okay. So let's go on to 4.4. I wish I hadn't lost those first 9 minutes that I was waiting for people to come in. I didn't realize the dean had called a meeting this morning at 10, so I'm going to have to leave fairly soon. Fortunately, it's here on the Bessemer campus. It's usually on Birmingham campus. She called it for here, which worked out. That was just good luck on my part. All right, so we're still in Chapter 4, Trigonometry. Now we're in 4.4, the trigonometric functions of any angle. Now this is sort of what we were getting at before when we did the sine of an angle to be 0.6. That's not one of our special angles. We now want to deal with any angle. Well, guess what? We're going to see, okay, here are the objectives in this section. Evaluate the trigonometric functions of any angle. Find the reference angles, and we'll define what those are. And then evaluate trigonometric functions of real numbers. Okay? The first part here is the introduction. And you start out with something that should be very familiar to you. The only difference is, last time we saw something like that, we dealt with first quadrant angles, acute angles. Now we're looking, the definition of trigonometric functions were restricted to acute angles. In this section, the definitions are extended to cover any angle. When theta is an acute angle, the definitions here coincide with those in the preceding section. So the definition of the trigonometric functions, any angle, let theta be an angle in standard position, okay, with x being the x coordinate for that, y being the y coordinate. Okay, standard position means you're measuring that angle from the horizontal positive axis. Okay, this time we're letting the theta, it still works for acute angles, but now we're letting it extend to obtuse angles. That's anywhere from 90 to 180 degrees, or pi halves to pi. We'll even let it extend further around to all the way around 360, 0 to 360, or 0 to 2 pi. Now, when you do this, the angle theta is the angle in standard position. X, Y are your coordinates, but now those x's can be positive or negative. The y can be positive or negative. In the first quadrant, everything was positive, okay? So these are the coordinates of a point on the terminal side of that angle theta. Now here's a key. Your r here, and it was true before, we probably just didn't say it too much, is the square root of x squared plus y squared. It's never, can never be equal to 0, okay? It's always a positive number. Notice it's a principal square root. So not only is it not equal to 0, it is greater than 0. So I wish they had said that as well. Not just said it's not equal to 0, but said it's greater than 0. Okay? Now for that to be, with that being true, then your sign of any angle theta is the y value, and remember that y value can be positive or negative, divided by r, but r is always positive. Okay? The hypotenuse is always positive. The radius is always positive. If this is a circle, r is always positive. The cosine is the x value over r. And remember, x can be either positive or negative, but r is always positive. The tangent is y over x, just like we have had before. And remember now, either y or x can be positive or negative. But x can't be 0. That's a new thing here. And cotangent theta is x over y, but now y can't be 0, but x and y can both be either positive or negative, but y can't be 0. Secant is r over x. Remember, that's the reciprocal of cosine, so that would be, the reciprocal of that, r over x. So r is always positive. X can be either positive or negative. That means, and of course, x can never be 0 for a secant, just like it can't for a tangent. The cosecant is the reciprocal of the sine function. So sine was y over r. The cosecant is r over y. And again, the r is always positive, and the y can be either positive or negative, but in this case can't be 0, just like it could for the cotangent. So get used to these ratio identities, well, these aren't ratio identities. These ratios that define these trig functions, you use them all the time. We used them on the unit circle. There, r was always 1, so we just said sine theta was y, cosine theta was x. Well, the thing is, that was because r was 1. Ever since then, we've used that as well. So get used to it. Remember it. Okay? I think I'm going to have to stop there. Sorry about that. I did not know the dean was going to call a meeting today. So we are only got a couple slides in there, maybe just one, I don't know. And anyway, we'll be starting on page 290, section 4.4. Now, if you had been here today, if anyone had been here today, what I was going to do, I thought we would get further because I waited 9 minutes, hoping someone was going to show up, and found out the dean called the meeting, so now I'm having to stop early. But if we had had our full either 45 minutes or an hour and 15 minutes, we would have gotten far enough in 4.4. I would have given the people here your first test, so you would have an extra weekend to work on it. I would still have done that if anyone was here right now, but no one's here, so you'll have to wait. And more than likely on Tuesday, we'll get far enough along so that I'll give you that test, take-home test, even if we haven't finished 4.4, but it won't be due until 1 week from the time we finish 4.4. All right, that's all I've got time for because the dean called a meeting, so sorry about that. I guess we weren't supposed to have this very much of this class. I'm glad I got something done, but we'll pick up and go on Tuesday.